Okay, good morning, boys and girls here and our friends at home. We're going to do more lessons, or another lesson today on area. And let's go ahead and read our learning target together so we'll know exactly what we're going to be doing today. On the count of one, class. 3, 2, 1. We can apply the distributive property as a strategy to find the total area of a large rectangle by adding two products. That is really long, and some of our classmates have already commented on how long it is. What are some important words in there? What are we going to be doing, Cam? Very good. Really important, the distributive property. And if you're good, you remember there was another name for the distributive property. You remember something that's a little more user-friendly. What else, Raga? Nice job, the break-apart strategy. So we're going to be using the break-apart strategy to find what? What are we going to be finding? Kalia?
We're going to be finding the total array.
The total area. The total area? And what are we going to be finding the total area of, Ori? Yeah, a large rectangle. And how are we going to be finding the area of that large rectangle, Eli?
By doing a division.
No, look at the learning target. By doing what? Lucas?
By adding two products.
Very good, by adding two products. And now my question is, do you know what a product is? Who can explain what a product is? Cam? Well, close, but not really. Who knows what a product is? Val?
A product is where is the total size of an array or of what you're counting.
Well, close. The product is our answer when we multiply, okay? So we're going to be taking two products and adding them together. So we're actually going to be using two concepts. We're going to be using equal groups when we multiply, because we'll have equal groups of the same number of units in each row, but then we're going to be using part, whole, because we'll be adding two different products, so it'll become part, whole. All right, so let's just review last week. So look up here, boys and girls. Afraid, could you put that in your basket, please, so you're not distracted by it. If I want to find the area of this rectangle, do I need to tile it? No, somebody said, no, I don't need to tile. If I don't need to tile it, how do I find the area of it then? Clear.
Find the area by the side ones. Like this one says 3 inches long and the top one says 5 inches long.
Okay, so what do I do with those?
You multiply those two.
Very good. So last week what we learned is we no longer have to tile to find the area of a rectangle. We can kind of picture the rectangular array within it. Remember, this is called an area model. So we would multiply our side lengths. 3 inches times 5 inches equals 15 square inches. All right, so there's just a little review of what you did last week. I was off on Friday, so I want to make sure you all understood that. Boys, those go in your desk. Gideon and Eli, in your desk, please. Thank you. All right, so now, first things first, let's look at this rectangle. Okay? How many rectangles do you see when you look up there? Or on your paper? How many rectangles do you see? Jackson, how many do you see?
C2.
You see 2. How many people see 2 rectangles? Okay, does anybody see a different number of rectangles? Corey, what do you see? You see 1. Okay. Braga, what do you see?
It's both 1 and 2.
Okay, it's both 1 and 2. How about it's Bell?
It looks like 3 because there's the main one and then the 2 smaller ones.
Very good, excellent. And that kind of fits right in with our learning target. We're already viewing it in this model we have here. So Val's saying she sees the main one. So I'm tracing it with my finger. Go ahead and trace the big one with your finger. Okay, that's one large one. And then a lot of people said I see 2 because they saw the 2 smaller ones. So let's trace the smaller ones with our finger. There's the shaded one on top. And then there's the unshaded one on the bottom, or the white one. Gray one, white one, however you want to say it. Okay, so we learned last week in order to find the area of the rectangle, we have to multiply the side lengths. Well, we don't know what these side lengths are, so Ms. Zimmer's going to help us back there. And she's going to use our square centimeter tiles, so watch her as she finds the side lengths. Okay? We're finding the area of the large rectangle. So she's going to find this side first, and once she does that, we can label it. Okay, what is the size of that side? What is the length of that side? Eli?
6.
6 what? Dress it up.
6 centimeters.
Okay, go ahead and label it 6 centimeters on your paper. Now she's going to tile the other side of that large rectangle, so you can watch her and count. Yes?
Is the one that we're finding right now?
It does look a little bit like a square. I'm not sure it is, but it looks a little bit like a shaped square. Okay, now, how many tiles did she use to do the other side of that large rectangle? Frey, you're up front. How many was it?
There are 8 centimeters.
8 centimeters. Very good. So we'll label this side 8. Okay. So what is the area of our large rectangle? Let's write a number sentence down at the bottom of the page. So the area, and you know what? I'm going to put L beside it. Do you know what L stands for? Area of large rectangle, okay? So everybody put area equals, put that little L by it. And what number sentence would we write for it? We would multiply the side lengths. So we would say 8 centimeters, which represents this side, times 6 centimeters, which represents that side. And if you know your facts, 8 times 6 is, help me out class, it is 48. 48 square centimeters. So we know that the total area is 48 square centimeters. We're not adding, multiplying 6 times 8. Okay? All right, now we're going to look at the area of the shaded rectangle. So Ms. Zimmer, if you could go back and put the tiles. We know this side of the shaded rectangle is 6. So let's just do the shaded one here. So watch her as she counts. What is that side of the shaded rectangle, everybody? 5 centimeters. So we're going to go ahead and write that here. 5 centimeters. Remember, the top didn't change. It's still 6 centimeters. Okay, what are side lengths of the shaded rectangle? 5 centimeters and 6 centimeters. What number sentence would we write to find the area of the shaded rectangle? What numbers would we multiply to find the area of the shaded? Lucas? 5 times 6. Very good. Okay, we would use 5 times 6 for the shaded. Okay, now let's come down here and let's find out the side lengths of the white rectangle. So we know this side is 3, so let's go ahead and write 3 centimeters. Ms. Zimmer just showed us, right? Do we know the other side length of the white rectangle?
Yes.
Okay, some people say yes and some people say no. What do you think? Val says yes. Why do you say we know the other side length?
Because, like the top side length or the...
I want to know this side length of this side length of this rectangle. How do we know?
We know it because it's 6, because the top one's 6, and it isn't like 4 on the bottom and 6 on the top, because then it wouldn't be a giant rectangle. It would be 2 rectangles that are touching each other, which you're not supposed to do.
Okay, or it would be a trapezoid. So, very good. So what Val reminded us of when she said this is 6, this has to be 6, so go ahead and label it. Remember when we learned earlier in this unit, opposite sides on a rectangle are equal. So we could have had Ms. Zimmer tile this side with the centimeters, but we're saying, we know what, if this side is 6 centimeters, then this side is 6 centimeters. Actually, guess what else? This side is also 6 centimeters. Okay. Now, what I want you to think about, Lucas, I'm going to put area of S. Does anybody know what area of S means? Area of the shaded rectangle. So Lucas said it would be 5 times 6. We all agree? 5 times 6. Go ahead and write that on your paper. Okay, what if we wanted to find the area of the, I'm going to call it U. U will stand for unshaded. What side lengths would we multiply to get the area of the unshaded? Well, it looks like this side is 3. And the other side is 6. All right, now think about it, boys and girls. 5 times 6 equals what? Equals 30. That represents this top part. So I'm going to put 30 square centimeters right in that top part. 3 times 6 is the unshaded. What is 3 times 6, everybody? 3 times 6 is 18. Let's go ahead and write it. Remember, you can skip count 6, 12, 18, or you can skip count by 3, 6 times. And so now let's put this down here, 18 square centimeters. So if we know the area of the top or shaded rectangle is 30 square centimeters, and we know the area of the bottom, the white or the unshaded, is 18 square centimeters, what can we do to find the area of this great big rectangle? Before we multiplied 8 times 6, but what else can we do? Think about our learning target. Kalia, what else could we do?
You could also, it says add 2 products together to figure out those sums to figure out the total area of that.
Very good. You just nailed what we're doing in our learning target. She said we could also add our 2 products, 30 plus 18. So what can we do to find the area of the large rectangle? We could add 30 plus 18 and get 48 square centimeters. Does everybody see that? It became part, whole. What does 30 represent then? Look at the picture. What does 30 represent? Ori. How about say the area of the shaded rectangle? What does 18 represent? Cameron.
18 represents one part and another part. One part's in the
Right, so what does it represent in this picture though? Raga.
18 represents the smaller.
The area of the unshaded or smaller rectangle. And then finally, what does 48 represent? Turn to your elbow partner, A partners, whisper to B partners, what does 48 represent?
48 represents 30 and 88 represents
Oh, yeah, because if they don't fit perfectly, because the template is not easy. All right, holy moly. Let's come back together. So what does the 48 represent? Who have I not heard from? Aubrey.
48 represents
Very good, the whole entire rectangle. So how did we find the area of this whole entire rectangle? Well, the first time we multiplied our side lengths. But then we said, you know what? We're going to do what our learning target says. We're going to break that rectangle down into a shaded part and an unshaded part. We're going to find the area of the shaded part, and we're going to find the area of the unshaded part. And then what are we going to do? We're going to add those 2 products. Okay? Now, find a clear space on your template there, because I want to write this just a different way. Now, remember how I said every number in a number sentence represents something? If we want to find the area of a large rectangle, we could say 8 times 6, right? Everybody agree? So go ahead and write that. 8 times 6. 8 times 6. Go ahead. Now look what I'm going to do underneath here. Okay, B partners. Let's look and see. How does this 5 plus 3 represent our picture? So B partners, talk to your A partners. How does that 5 plus 3, how do you see that in your picture? Do you agree?
5 plus 3 represents 8 because 5 plus 3 equals 8.
So it would be 5 plus 3 would just end up being 8 times 6.
Okay, to infinity. Very good. All right, so who wants to share what you and your partner discussed? How do you see that 5 plus 3 in our picture here? How does it relate? Beth?
It relates because the 5 plus 3 is the 8 and the number 6.
Okay, 5 plus 3 is replacing the 8 in the number sentence. In other words, what did we do? We decomposed 8 into 5 and 3. Think about it. Think about a number bond. All we did was take 8 and we split it into 2 parts, 5 and 3. The 5 represents this side of the gray rectangle. The 3 represents this side of the white rectangle or the unshaded rectangle. Okay, very good. So now our next line that we're going to write is we're going to show how we're going to break that down and get an expression for both the white rectangle or the gray rectangle and the white rectangle. So now we're going to take our 5 and we're going to distribute it to the 6. So 5 times 6. Write this right underneath here. So friends at home, you're going to want to write this. And to that, we're going to add, now we have to write the multiply 3 times 6 as well. That's really what we're doing, boys and girls, all those steps. We took 8 times 6, which was the area of the entire rectangle. We decomposed the 8 into 2 parts, 5 and 3. And then we had to multiply 5 times 6 and 3 times 6. And finally, what do? We add those 2 products. We already know 5 times 6 is 30. And we know 3 times 6 is 18. And we add 30 plus 18 and we get 48. So I don't know about you, but that's kind of fun for me. It's like a puzzle. When I look at that, it's a puzzle. I found the area of the top and the area of the bottom, and I could add those to get the area of the whole. How do we feel about that? Fifths to 5. How are you feeling about that? We just did exactly what our learning target said, didn't we? We found the area of this large rectangle by decomposing it into 2 smaller rectangles, finding the area of each one, and then adding. Okay? We're going to do a little bit more practice. So Ms. Zimmer and I are going to come around with another large rectangle. Actually, I think there's 2, and they're on grid paper. Oh, no, not really. Thank you. You put your name at the top of this, please. You can, but you don't have to if you wait. All right. Everybody have one of these. So if we look at this, boys and girls, we have 2 rectangles, separate rectangles. We're going to find the area of each one using the distributive property. What are we going to use? Distributive property. Okay? So let's look at this one big, large rectangle here. What are the side lengths? Go ahead and count and find the side lengths of the great big one. Okay, the top one was easy. What did you find for the side length going across the top? Kim? 6 centimeters. Very good. And we know it's centimeters because there's centimeter grid paper. How about this great big long side over here? What did you find for that? Lori?
I found 10 centimeters.
Well, no, the whole thing. The whole thing. 13. The whole thing is 13 centimeters. Does everybody agree? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Remember, we find the side lengths by counting the number of tiles on the side. Now, if we wanted to find the area of this large rectangle, what would we have to write? We would have to write area equals 13 centimeters times 6 centimeters. Does everybody agree? We multiply the side lengths, right? Well, I don't know about you, but I don't know too many 3rd graders who have learned their 13 specs. So what are we going to do? What did they already do for us with that large rectangle? Look at it. A partners talk to B partners. What did they do with the large rectangle? Your A. This large rectangle, what did they do to it? What did they do to the large rectangle? Well, that's what you're doing, but what did they do to it? Just look at it, what did they do? What? All right, back together again, boys and girls. Raghav, would you like to share? What did you and your partner say? What did they do to the large rectangle?
They shaded in 10 of the square, so you could do 6 times 10, and then 6 times 3.
Awesome. They decomposed this large rectangle into a rectangle that, let's label the top part, is 10 centimeters, and then 3 centimeters. Go ahead and label your sides. Okay, we need to do that, bud. Okay, now, instead of doing 13 times 6, in order to find the area of the shaded part, I can write the area of the shaded part equals, well, here, let's just do it, equals 10 times 6. What does that represent? It represents the area of the shaded part. And I'm going to put a little S above here to show that that's the shaded part. Okay, so we have the shaded part. Now, what are we going to add to it? The area of the unshaded part. So we're going to put another expression in here. Well, what are the side lengths of the unshaded part? We have 3, and what's the bottom one? It is 6 again. We can count our tiles, or we also know if this is 6, then the opposite side has to be 6. So what expression will we write for the unshaded? We will write 3 centimeters times 6 centimeters. And I'm going to put a U above that. What does the U stand for? Unshaded. I suggest you do that so you know exactly what your two expressions represent. Okay, now we have 2 really easy facts. Jackson, what is 10 times 6? 60. Let's go ahead and write it. I don't know about you, but I always love a 10 fact. And then what is 3 times 6? Eli, what's 3 times 6, bud? Nice job. That is 18. And when you add to multiples of 10, it's pretty easy. I bet we can all do that mentally. 60 plus 18 equals what, class? 78. What is the area of my large rectangle? The area is 78 square centimeters. This is one of my favorite lessons because we just did exactly what our learning target said we were going to do. We took a large rectangle, we decomposed it or broke it apart into 2 smaller ones. We found the area of each smaller one and we added them together. To make this more clear, let's go ahead and put 60 square centimeters in this part. So we know exactly what the 60 represents. And then down here we will put 18 square centimeters in this part. What did we do? We added 60 plus 18 together. Okay. We have another example there. Go ahead and label the side lengths of that one large rectangle. All right, nice job, boys and girls. Going across the top, how many centimeters is this? Owen. 7 centimeters. Going down this long side, what did you get, Kim? 15 centimeters. Now again, I don't know about you, but it's hard to multiply 15 times 7. So who has a suggestion on how we can decompose this? In other words, how many rows do we want to shade? What would you suggest? What would make it easy, Ori? What did we do in our last example? What is it easy to multiply by? 10. 10. Let's all do 10. So let's count down 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We'll draw a line. What did we just do? We decomposed our large rectangle. And if you want to lightly shade it with your pencil. And let's label that side length. That side length will be 10 centimeters. Well, if that side is 10 centimeters, then what is the side of the bottom or unshaded? It will be 5, because 10 plus 5 makes 15. So we'll go ahead and label this 5 centimeters. And if you want to, down here, you can also label 7 centimeters, just so you have a side of the white rectangle shaded. All right, let's write a numerical expression for exactly what we did. So we're going to write area of L, which is the area of the large rectangle. You're going to need more room than that, so I write that in here. Okay. Well, to find the area of the large rectangle, we would take 15. I'm going to leave off my labels for now, just to make it a little bit easier. 15 times 7. Everybody agree? 15 times 7? Which one of those numbers got decomposed when we decomposed our rectangle? Was it the 15 or was it the 7? Look at our picture. Which numbers got decomposed? Kalia.
The number that got decomposed was 15.
Very good. And what did it get decomposed into? So she's saying the 15 got decomposed. What did it get
It got decomposed into 5 and 10.
Nice job, girl. So I'm going to write underneath that I decomposed 15 into 10 plus 5. So everybody see that on our picture. Pictures remain really important, boys and girls, for our math work. And the other side remained 7. Yep, 10 plus 5, because look at 10 plus 5 makes 15. And then we're multiplying. All we did was take 15 and decompose it. We didn't do anything with our 7. 7 is still there. Now, let's go ahead and write an expression for the top rectangle. We'll take the 10 and we'll multiply it by 7. And what does that represent? I'm going to again put an S for shaded. I suggest you do that. See, I wanted all of this under there, just like so 10 times 7 represents the area of the shaded. I took the side lengths, 10 multiplied by 7. To that, I'm going to add the area of the unshaded, which would be 5 times 7. So I'm taking my 5 and multiplying it by 7. And I'm going to put a U above that for unshaded. Does everybody see how these expressions relate to my rectangle? 10 times 7 represents the top, 5 times 7 represents the bottom. I went from 15 times 7, I decomposed the 15 into 10. All right, everybody, what's 10 times 7? It is 70. What is 5 times 7? It is
5 times 7 is
35. If you can add that mentally, go ahead. If you can't, do the algorithm. What is 70 plus 35? 70 plus 35 is?
105.
Nice job, Eli, 105. What is the area of our large rectangle, boys and girls? It is 105 square centimeters. And now, just to make clear, I want you to go back. We're going to write 70 in which part of our rectangle? We're going to write it right here, 70 square centimeters. 10 times 7 makes 70. Where do we put the 35? The 35 goes in the white part, 35 square centimeters. What did this become? Part, whole. We added 2 products to find our total. Okay? All right, so friends at home, I want you to upload the templates for you, and it's really important that you show this work here just like I did on your templates. So you're showing how we are decomposing the rectangles. Also want to make sure that you're writing the areas in each of the smaller rectangles so you can see the part whole. Okay, thank you. It was, we didn't run more example, we didn't have that one.